We want to look at writing ionic equation. How do you write an ionic equation? For example, you're told that write, let me give this question, write the overall ionic equation. Write the overall ionic equation equation for the following reaction. Lead nitrate added to sodium sulfate. So if we have an equation where lead nitrate is reacting with sodium sulfate, so assume you don't have the equation, so you have to write the equation, balance the equation, write the status. So let us write the equation. Lead nitrate plus sodium So sometimes it is a challenge. What are the product of this? So what happens is that the cation in this side will take the anion this side, and this cation will combine with this anion this side. So we are going to form lead sulfate plus sodium nitrate. Now before you write, once we have finished, now let us write the status. All nitrates are soluble, so all of them are aqueous. All sulfates are soluble except lead and barium and calcium, so therefore this one is aqueous. Lead sulfate is a solid because all sulfates are soluble except lead sulfate, calcium sulfate, and barium sulfate. All nitrates are soluble, therefore we write AQ. So somebody was asking, how do you know where to write aqueous, where to write liquid, where to write a solid, like that? So it is easier to understand that after you have understood the solubility of salts. Which salts are soluble in water and which one are insoluble? For example, we know that all sulfates, they form a colorless solution when dissolved in water. But lead sulfate, barium sulfate, and calcium sulfate, they form a white precipitate, therefore they are solids. They don't dissolve. So that is the basis of what you're doing. So after doing that, now we need to break these equations, this compound down. This is lead. Lead is valence 2 plus nitrate ion valence 1, but there are 2 of them here, you put 2 plus sodium ion, there are 2 of them, plus sulfate 2 minus. All of these are aqueous, 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 aqueous. We come here, we retain lead sulfate plus 2 sodium plus 2 nitrate, aqueous, aqueous, solid. I know a question which could be ringing in your mind is that why didn't I write lead sulfate in this form? Why didn't I break ion 2 lead 2 sulfate like I've done to the rest? If the status of a compound is a solid, if the status of a compound is a liquid, and if the status of the other compound is a gas, you don't touch, you don't write the ionic equation of a liquid, of a gas, and a solid. You want to rewrite ionic equation for substances which are in aqueous form. Let me repeat that. Ionic, you break the substances into ions, those substances that are in aqueous status only. If a substance is in solid state, gaseous state, liquid state, you don't touch them. They remain the same. They remain the same. We are going to write more so that you can see. So now we have written this one like this. There are ions that you are seeing on the left side and you are seeing them on the right side. Therefore, it means they did not undergo any chemical change. So if they did not undergo any chemical change, then they are called spectator ions and they are not important to us. Therefore, what we do, we cancel them out. So sodium, 2 of them are here and another, so you cancel them out. The nitrate is here and the nitrate is here, you cancel them out. So what is remaining, as you can see, are the ions that form the solid. So lead, 2 positive, aqueous, plus this, aqueous, they are the one that forms lead sulfate, which is the solid. And this is the overall ionic equation in this question. That is the. Let us consider the reaction between sodium hydroxide plus sulfuric acid we are going to form the salt sodium sulfate plus water. So the first thing you do, you write the status. Before that, even balance the equation. We have 2 sodium here, put it to here. So we have 4 hydrogen, so you put it to here to balance the equation. The next thing, after balancing the equation, write the status. Sodium hydroxide is aqueous, sulfate is aqueous unless it is concentrated, and then this one is aqueous, this one is water. So for us to write the ionic equation of this reaction, consider only the substances that are in aqueous form. Anything that is in a liquid form, in a gaseous form, and a solid form, don't touch it. You don't write the ionic equation of that substance. So let us write the ionic of sodium. So we break this as follows: sodium ion, but there are 2 of them, 2, plus hydroxide ions, there are 2 of them, OH, minus 2 of them, they are in aqueous state. Then plus sulfuric acid, you break it to 2 hydrogen plus 1 sulfate. Both of them are aqueous, they are aqueous. To the right side, we are going to break this into 2 sodium, aqueous, plus the sulfate, 2 minus aqueous, and then plus 2 water, liquid, 2 water, which is the liquid. I told you that those ions that you will see on the left side and they appear on the right side, it means that they have not undergone any change. Therefore, they are called spectator ions. We remove them, we cancel them out. So you can see sodium is here, 2 sodium here, we cancel them. Sulfate is here and we have another sulfate here, therefore we cancel them out. So what is remaining are the 2 ions which combine to form water, which is in liquid form. So hydrogen ions, 2 of them, will combine with the 2 hydroxide ions to form 2 waters. Now, since the ratio here is 2, we can divide by 2, and this one is 1 term, another term, another. So we can divide by 2, divide by 2, divide by 2, divide by 2, and the overall now ionic equation is hydrogen, aqueous, plus hydroxide ion, aqueous, which is forming 1 mole of water liquid. And this is the overall ionic equation. I think that one is very clear, very clear. We have another equation here. We have barium nitrate reacting with the zinc sulfate to form barium sulfate and zinc nitrate. As you can see, that barium has taken an ion this side, and the zinc here has taken the ion this side to form this. So now we have this our overall equation. We want to write the ionic equation. Somebody asked, is there a way I can write the ionic equation without doing all of this, without breaking this one like this? Yes, there is a way you can write without breaking those. So long as you have understood what you are doing, this is very easy. So what you do, first let us write this. Barium nitrate, our nitrates are aqueous, so it is A, Q, all of them are aqueous. Zinc sulfate is in aqueous form, catalyzed solution. Barium sulfate is insoluble, therefore it is S. Zinc nitrate, all nitrates are soluble, so it is aqueous. So the shortcut is that you don't need to write, just write the ions that are forming the solid only. What is the name of our solid? Is barium sulfate, meaning our solid here contains barium ions and sulfate ions. Therefore you go ahead and write barium sulfate only. Therefore you write barium 2 positive, barium 2 positive plus the sulfate, aqueous, because they must be aqueous to form the solid barium sulfate. So you have written the equation without breaking down the equation like we did here. So and this one is also very correct.